So first of all, on behalf of Struct Soft Center, I would like to welcome you all in this introductory session for the upcoming live training program under the title of Design of Complete Structure using CSI, ETABS, STAT RCDC and Advanced Excel. So here first we need to understand what are the important essential things over which you have to take the command and what skills you need to adopt, you need to practice to get in yourself. Then only you will become a professional structural engineer. Then you will be able to design any kind of structure. So what are the important things? That is very first thing to understand. And thereafter we are going to talk about this training program. What we will cover in this training program, I will talk about all those things on later stage. But before of that, if you want to become a structural engineer, so what are the essential things? Learning about the software is not only the solution. Learning about the software commands is not only the solution. So first of all, have a look over this figure and try to understand what are the important things that will make you a professional structural engineer. So if you are going to look into the market and if you are going to look into the industry and want to become want to get the entry in any company, in any consultancy, in any MNC as a structural engineer, so you have to get the command over all these four pillars. You have to take the commands over all these four requirements. So what are those? So very first is the design softwares. We will talk in detail about each of these individual requirement in detail, but in short, what are the different points? So very first, the design softwares. Second is the structural concepts, design basic concepts. Thereafter, the design codes. And the last one is the experience. So these all four requirements, these all four skills, these all four knowledge will make you a professional structural engineer. So in the current scenario, if you are looking for the job and if you are going to ask a job, so very first question the interviewer is going to ask, how many softwares you are knowing. Very first requirement is what? How many softwares you are knowing. If you are not having the knowledge, if you are not having the command to handle the software, you will lose the opportunity. So very first requirement is what? You need to look into the industry, what are the different softwares. And after knowing the software, you need to know what are the application of all those softwares. What is the advantages of all those softwares? In which particular application, in which particular field that software will suit. So there are so many softwares are available for the design purpose, like CSI ETABS software there, STAT Foundation is there, STAT RCDC is there, CSI Safe software is there, CSI Bridge is there, Tekla is there, Perform 3D, SAP 2000. There are so many different softwares are available. So it is always not important to go for all these different softwares. You need to find out the need where you are going to work and there what softwares they are using. Or if you are going to start your own consultancy, so if suppose you want to work independently, so which software you have to learn, you have to find that first. Unless and until you are not getting your requirement, you will not able to find the right software. So very first thing is what? Having the knowledge, having the command about the software. And when you come to talk about the software, so learning of software is not only the solution. Like most of the training centers, what they are doing, they are just teaching about the commands of the software. So after learning of the commands of the software, you will again be handicapped. You are not getting the confidence. So the concept is very important. If you are going to perform any activity with the software, any command you are going to use in the software, so you should have the knowledge about whether why we are going to perform this command. What is the concept behind it? What will happen after performing this command? So that is what knowledge about the software. Now second question they will ask about the basic concepts. Very important. Yeah, suppose you are getting the knowledge about the software, you are having the commands of the software, so that is not the solution. You need to have the basic concepts. What are the basic concepts? Like what are the different types of the grades of the concrete? In this situation, what grade of concrete you have to use? What are the different types of the loadings? How to do the calculation of the loadings? Line loading, frame loading, area loading, how to do the calculation, how to do the calculation for the floor finish. In academic times, we are getting the data, this much floor finish load, this much is the lie load. So how that lie load, how that floor finish loads are coming, that you should have the knowledge about its calculation. What are the different types of the loading? That is what? Gravity loading, lateral loading, static loading, dynamic loading. How your structure is going to be deformed, how the beam is going to be deformed, what with the bending moment diagram, what with the shear force diagram. If you are having the knowledge about all those things, then only you will be confidently able to use this software. If you are not having the basic concepts, if you are not knowing the what is the densities of the concrete, what is the density of the steel, how to do the calculation for the earthquake loading, how to do the calculation for the wind loading, what are the important parameters for the calculation of the earthquake loading, wind loading, so you will not able to use this software. There will be no use of this software. Software is just a tool, like your your calculator. The knowledge is in our mind, so that should be in our the basic knowledge is very important. Without a basic knowledge, without a basic concept of structural response, structural properties, you will not able to use this software effectively. So this is what the second requirement, and this you will get from your academics. And the third requirement is what? The design codes. This is the most important one. Why? It is because if you are not going to learn these design codes, if you are not going to follow these design codes, so what will happen? You are going to make your structure as uneconomical as well as unstable. As a structural engineer, we have the two requirements. We have two responsibility. One is to make our structure as stable. Whatever the life of the structures we are going to expect, like 50 years, 100 years, whatever the life of the structures we are going to expect, so up to that life, your structure should be stable. As well as you have to achieve the economy in the design, economy in the construction. So how you will get the economy as well as stability of your structure? Only on based on the design of the based on following the design codes. So what are the different design codes are available? So IS 456 2000 is the basic code for the design of RCC structure. IS 800 2000 code for the design of your steel structure. What for IS 875 part 1, part 2, part 3? You need to know that. What are the important clauses are there? What are the meaning of that clauses? How to implement that clauses in our software, in our manual calculation? That is needed to know. IS 1893 2016 code is there. IS 13920 2016 code is there. Ductile detailing, ordinary detailing. What does mean by the ductile detailing? What does mean by the ordinary detailing? When to perform the ductile detailing? When to perform the ordinary detailing? If you would like to follow the IS 13920, so what clauses are there? Importantly, you have to follow. SP16, what is the role of this SP16, SP34? What for IS 1904 have to use, 2911 have to use. So these are the different codes. If you are not going to follow these design codes, what will happen? You are going to make the harm to your client, to your structure as well. It is just similar to that of if you are moving over the road and you are not going to follow the rules and regulation to moving over the road. So what will happen? You are going to harm to yourself as well as to others by the accident. The same thing is going to be happen here. If you are not going to follow the design codes, what will happen? Your structure is going to become uneconomical. You are going to waste the money as well as you are going to lose the stability of the structure. Your structure is going to be damaged. And all the people who are going to live in that structure, they lose their life. So that is what the drawback if you are not going to follow the design code and if you are not going to learn the design codes. So very first requirement is what? Design software. Thereafter what? Basic concepts. And third one is what? The design codes. And the fourth one, can anyone expect what is the fourth one? I have already discussed, but can you tell me what is that? Exactly. The last and the most important is the experience, and you all agree with my this statement that without of experience, no one are ready to give the job. No one are ready to give the chance. Am I right or wrong?
Right, sir. You're
Yes.
right, sir.
Everywhere, if you are going to look and if you are going to ask a job, whether you have completed your bachelor, you have completed your master, even you have completed your PhD. If you are going to ask a job, so they will first ask a question: experience. How many year of experience you are having? Now second clarity I would like to give here, when they are asking about experience, so they are not going to count how many years you have worked. They are not going to count how many years, 2 year, 4 year, 5 years. Their intention is to know how many real example projects you have dealt on your own, you have completed on your own, from basic, from start to end. That is what the intention. Real example projects, real problems you have dealt with. Because unless and until you are not going to feel with the you are not going to face the real example projects, you will not come across the all the problems. If I'm giving a normal building dummy project, so that is very easy. That what the training centers are doing, they are just giving the dummy project scare building, and they are just teaching about how to assign the load, and they are just teaching about the commands of the software. So that is what the very worst thing. You are feel handicapped after completion of that programs. So when you are going to deal a real example project, so you have to take a lot of decisions. Like you need to know how to read the architectural drawing, how to decide the column position, how to decide the orientation of the column, and then how to decide the orientation of the shear wall, whether it is needed to provide the shear wall or not, how to decide the preliminary sizes. When you are going to start the work, we will talk in detail on later stage. When you are going to start the work, you have to decide the preliminary sizes of the elements. How what should be the minimum percentage, what should be the minimum maximum percentage, whether I can reduce the percentage over the height of the structure or not, where the more percentage of reinforcement will be required, what type of foundation I have to choose, what grade of concrete I have to choose, what I have to do if my column is going to be fail, how to optimize the design, how to reduce the demand of the percentage of reinforcement. So lot of practical challenges will be there. What to do if my ground level is not at the same level, there is an undulation, there is a slope, what to do in that situation. So these are the real challenges, and that will make you a professional structural engineer, that will add the experience in your profile. So overall, this is what the four requirements. Without of this, without of thinking about all these four requirements, if you are planning to, if you are thinking that you will become a structural engineer, so you are wrong totally. So here I am asking that do you have the command over all these four requirements? So if your answer is yes, that's well and good. You are on the right path. You will become a structural engineer. But if your answer is no, then you don't need to worry about all these things. We are presenting this training program that is going to cover all that four aspects, all that four requirements, all that four skills. By considering the current scenario of the industry, to get the proper job, to get the good job in the consultancy or in MNC or in companies, or if you want to start your own firm, if you want to start your own consultancy, so to what things are essential, so that all we are trying to cover with this training program. So we will talk in so this training program is going to start from 18th of May 2023. The timing of the training will be 7:30 to 9 p.m. in evening. So let's talk in detail how this training program is going to be conducted, what is the content of this training program. Okay, so we'll talk in detail. So you all are ready to have a look over the content of this training program and conduction plan. So this complete training program is consisting of three levels. One is the first one will be the beginner level. We will start the training from the beginner level, then we will jump to the intermediate level, and in the last we are going to see the advanced level. So those who are not having any knowledge about the software, any knowledge about the concepts, so they don't need to worry about. For them, we are having the beginner level. So in the beginner level, what we are going to cover in this beginner level, first we are going to talk about the introduction about the software. What is the past of the software? What is the history of the software? Thereafter, we are going to talk about the validation of the software. Like software is just a tool, as I earlier told you. Without like if you are giving the wrong input, you will get the wrong output. It is just similar to that of garbage in and garbage out. If you are giving the wrong input, software will give you wrong output. But if you are giving the right input, you should get the right output. So sometimes what will happen, we are giving the wrong input and we are expecting that we will get the right output, or sometimes we are giving the wrong input and expecting the right output. So in all that situation, how to validate the software, whether the software is giving the right result or not. For that, we are taking the simple example sample projects like truss, like beam, like column, and we are trying to know whether the softwares are giving the right result or not. So it is why we are taking this validation stage, because it is building the confidence in the participants. So you will get the confidence, whatever I'm going to do, it is what having the proof. What I'm going to do, it is having the proof. So validation of the software. Thereafter, we are going to talk about the in deep about the software. very deeply we are going to cover the software, understanding the what are the different file formats of the software, how to do the basic settings, how to do the advanced settings, how to do the modeling, how to do the analysis, what are the different commands of the analysis, how to do the load assignments, one story, all stories, similar story concepts. There are so many things. Snap option is there, set display option is there. So we will make you a master for this software. How to use this software by talking all the commands, all the basic settings. Okay, so see, very first introduction, then validation of the software, then commands of the software, and thereafter when you become a familiar with the software, when you become confident with the software, we are going to take a very simple and dummy project, very simple and dummy project to give the experience how to do the gridding, how to do the modeling, how to do the assignment of the load, how to making the definitions of the material properties, section properties, and so many things. We are taking you step by step. Directly we are not going to take a very complicated stage. So with this sample project, again we are making you comfort with the software. So after all of this, we are going to do the modeling, we are going to do the assignment of the load, we are going to do the performing of analysis, we are going to modeling of the staircase. Lot of things we will teach you. And then the objective of this first level is that making a confident with the software, as well as familiar with the software. Unless and until you are not becoming a familiar and confident with the software, you cannot go for the real example projects. Okay, so those who are not having any knowledge about the software, so they don't need to worry about. We are having the beginner level for them. Then once you complete the beginner level, we are coming to the intermediate level. And this intermediate level, not like others training center, we are going to again take a dummy project. Here we are going to take a real example project, complicated projects we are going to cover. This kind of architectural plan we are going to cover. This kind of architectural plan we are going to cover. Is it the easiest one or complicated one? Just tell me yes or no. Hello, yes, I'm audible.
It's a moderate concept.
Okay, it is a complicated, it is a moderate type of the structure, you can say yes. So these all are these design steps for the completion of any real example project. So very first is detailed study of complete architectural drawing. So those who have completed their bachelor, those who have completed their masters, they are not even having the knowledge how to read the architectural drawing, what important things we have to see in the architectural drawing. If at the ground level the parking is there, at the first level is any other arrangement is there, commercial, residential combine is there, so how to read the architectural drawing? Unless and until you are not understanding the architectural drawing, you cannot proceed further. Thereafter we have to prepare, we have after reading of the architectural drawing, you have to decide the preliminary section sizes of the elements. You have to decide what preliminary section sizes of the elements. So we will talk in detail what are the expert recommendation, what is the codal recommendation, what is the basic manual calculation for deciding the preliminary sizes of the column, for deciding the preliminary sizes of the beams, for deciding the preliminary sizes of the slabs, for deciding the preliminary sizes of the shear wall, for deciding the preliminary sizes of every elements. Because actually we have to prepare the structural framing plan. So before of that we need to decide the preliminary section size, and there are a lot of things to discuss, because your architectural arrangement will also plays an important role for deciding the preliminary section sizes of the elements. So with all of that discussion, we will prepare the structural framing plan by positioning of the column. So this is called as structural framing plan. And what how to prepare this structural framing plan in CAD, what important things you have to keep in mind, okay, what steps you have to take, everything, what Excel sheets you have to take, what manual calculation you have to consider, you have to do for finding out the preliminary section size, okay, how to decide the orientation of the column, orientation of the shear wall. So with all of that discussion and decisions, we have to prepare the structural framing plan like this. After that, we have to draw the grid lines. We have to draw the center line plan. What does mean by the center line plan? What does mean by the grid lines that you need to learn? And what are the different methods for preparing the grid lines in the ETABS software. Offset point method is there, using ETABS template option is there, export and import option is there. If you would like to directly import this framing plan from ETABS software, from CAD to directly in ETABS software, what steps you have to take, what cares you have to take, what unit consideration you have to take, that we'll talk in detail, right? So after all of this, what next? We need to start the modeling. We need to what? Define, like have a look over this. We need to define the material properties. How to define the material properties, what are the densities of the material, how to do the calculation for that, everything we'll talk about in detail. Then how to define the section property, material properties, everything. What does mean the diaphragm concept, what does mean the pier labels, when to assign the pier label, why it is needed to assign the pier label, what does mean by the functions, what does mean by the load patterns. This all comes in the definitions. This is a very important thing. Your work with the software is going to start with the definitions. You have to set the list of the definition, what loads you would like to consider, what load combinations you would like to consider, everything we will discuss in detail. Whether you want to assign the earthquake loading or not, whether you want to consider the wind loading or not, in which in which situation you have to consider that, everything we will discuss in detail. After setting of all these definitions, your work is going to start for the modeling of different elements. So very first, so we will talk basic approach for the modeling. We will discuss in detail the advanced approach for the modeling also. So very first, we have to do the modeling for the columns, we have to do the modeling for the shear walls. Why it is needed to model for the model column first, why it is needed to model the shear wall first, we will talk in detail by the concept, by the reasoning, with the reasoning in our training program. So after this, we need to model the columns. So how to do the modeling, how to positioning of the column, how to change the orientation of the column, everything we'll discuss in detail. After all of that, we have to do the modeling for the beams. We have to do what? Modeling for the beams. How to do the modeling of the beams? If suppose the curved beam is there, if suppose the inclined beam is there, if suppose any zigzag type of the beam is there, so how to deal all that kind of complicated modeling of the beams. How to do the modeling with the replicate option, with the all story options, similar story options, that all we will discuss in detail. So here we have to do the modeling for the beams also. After that, how to do the modeling for the slab, that we will talk in detail. How to do the modeling for the slabs, how to do the modeling for all different elements. So after this modeling of the slab, you can see your model like this. This is what the completion of the model, with the modeling of the column, with the modeling of the slab, with the modeling of the shear wall, everything. Can anyone tell me what next step if our model is ready? Can anyone tell me? Hello.
Loading.
Very true and very correct. Yes. So next step is what? Loading. But like here, it is very easy approach, very easy step to assign the loading over your structure. But basically, we are not knowing how to do the calculation for loading. Okay, which code will tell you about the loading? What load you have to assign? How much the live load you have to assign to your structure? Okay, so IS 875 part 2 will tell you about the how much live load you have to assign. IS 875 part 1 will tell you about the densities of the materials, and through that you can calculate the dead load of the element, dead load or floor finish load over your structure. So how to do the calculation for that, for the load, we are having the detailed description. Okay, how to do calculation the floor finish load over your structure, over your slab. So we will discuss in detail how to do the calculation for the wall load, and after calculation how to do the assignment over your frames, over your slabs, over your column point load. If suppose you want to assign point load over the beam, if you would like to assign. So every load we will talk in detail. Thereafter, how to do the calculation for the earthquake loading. So when you go to define section, when suppose if you would like to assign the earthquake loading, so here how to do the how to do the calculation of the earthquake loading manually, then how to validate with the software, that will talk in detail. What is the role of the time period, what is the role of response reduction factor, when to consider 3, when to consider 5, and the reason behind. Many of you may say that okay, for the special movement resisting frame, we have to consider the response reduction factor 5. But if I'm asking the question, why the code has given the 5, can anyone tell me?
No, sir.
No. So the code has given the value as 5. The code has given the value as 3. If you are going to use the special movement resisting frame, if you are knowing what does mean by the special movement resisting frame, that is good. And what does mean by the ordinary movement resisting frame, that's good. So for special movement resisting frame, code has given the value we have to use as 5. For ordinary movement resisting frame, the code has given the value to use as 3. But I am asking that why the code has given the 5, why the code has given the 3, why the code has given the importance factor as 1.2, why the code has given the zone factor value as 0.16. This reasoning will not be given by any of the trainer. So this is what actually the concept. If you are going to put anything in the software, so you should have the knowledge, you should have the background concept of that action. What will happen if I'm going to increase the time period? What will happen if I'm going to reduce the time period over your structure? Many times I'm getting the call that after assigning of the earthquake loading, my structure, my member is failing. After increasing the time period, my member is failing or passing. They are not knowing the reason. They are just going to put the value and going to perform analysis and getting the value, but not going to consider the not going to take into account the concept. Without a concept, without a basic knowledge, structure knowledge, and mathematical knowledge, you will not able to use the software effectively. Keep in mind. So I will talk everything in detail with reasoning. Load cases, suppose if you want to assign the loading over your structure, okay, so load like uniform load sets. So if suppose by normal approach, if you are going to assign the load over the model, over the slabs, so it takes time. But option has given by the software as uniform load sets. So how to use these uniform load sets to assign the work, assign the loading over your structure within a short period of time. Then how to define the like a dynamic loading response spectrum, time history, p delta analysis, lot of what is the concept of diaphragm, when to assign the diaphragm, how to assign the diaphragm. Okay, so many things is there that we'll talk in detail. So that is what about the modeling, about the assignment of the load over your structure. After assigning of the load over your structure, the next step is what you need to perform the analysis. You need to and before of performing of analysis, you need to what you need to make a first is what you need to prepare your model for the analysis. So what important stages are there for the analysis? What settings you have to do before of analysis? After all of that settings, you have to start for the analysis. So here I'm not going to talk all those things in detail because it takes a lot of time, and that much time we are not having to go for the discussion of all those things. So I'm going to perform the analysis here. Just click over the analysis. You have completed the analysis and you are ensured that your analysis is what right. What next step? You have to proceed for the design. Okay, you have to complete the design. So before of the design, you have to do lot of settings, lot of important settings. Without of that setting, if you are going to perform the design, definitely you will get the wrong result. Most of the times, even our participants or some unknown person also are contacting with us, like they are asking, my column is failing, my beam is failing, what to do with that beam, what to do with that column. So if I'm going to if I'm checking their model, okay, when I'm checking their model, so basic things they have not executed, then how they are expecting they will get the right result, right? So like it is not only after the completion to click over the design result and design will be done, and that design you can trust over that design results. This is not the real practice. This is a big blunder. Try to understand. So you have to do the first settings. Before of the modeling, some settings are there. Before of the analysis, some settings are there. Before of the design, some settings are there. Likewise, after each steps, checks are there. Like suppose you are going to do the modeling. So after the modeling, checks are there, whether you have performed everything right or wrong. After the analysis, some analysis checks are there to ensure that whether the analysis is right or wrong. After the design, some checks are there whether the design is properly completed or not by the software.
So a lot of things are there for the completion, and with the right practice to avoid the blunders. Okay, so suppose I'm going to perform, I'm not going to cover all those things here, I'm just going to click over this design. So once you click over the design, the software will design your structure completely and will give you design results, and you should be capable of interpret, or you should capable to validate that design result. So you need to ensure whether all the members are passing the design check or not. You need to know what does mean by these numbers. Here the some top and bottom numbers you are getting, some of these with 3 digits, 4 digits, what it means. So these are the reinforcement for the beams. Some in vertical, here it is what reinforcement is showing. These are the reinforcement for your column. So you need to ensure that whether the software is properly following or not your code, whether it is following the minimum and maximum reinforcement criteria were suggested by the code or not. Okay, and also suppose this particular beam if I am taking, so the values that you are getting here as 980, 220, 1110 mm, so these mm square, these are the reinforcement areas required at the top, required at the bottom, required on the left, required on the right. So there is a very interesting discussion about the design, detailing, scheduling of this particular beam. But here again, if suppose this beam is failing, so I just want to know what is the reason of the failure. And or in some situation, if suppose the reinforcement requirement is we are getting very high, which is as per our expectation is very high, then you have to ensure whether the software has done this design right or wrong. You have to validate the result. So you need to look inside of that particular beam. What is the shear force? What is the bending moment? What is the torsion? What is the movements? How much the torsion, how much the shear is there, and with that all values you have to cross check with the manual design of the beam. We are having this excellent level of advanced Excel sheet for the design of the beam. So with this Excel sheet you can design every type of the beam, as fixed beam, as a simply supported beam, as cantilever beam, as continuous beam, all that kind of beam you can design. So by taking this analysis data of this ETABS software for this particular beam, if suppose you are getting the result here, so I can validate this result by my advanced Excel sheet. Okay, so like then only we are going to ensure we are going to trust on the results of the software, and we will take for the design, for the schedule and detail. So like for that kind of things we are trying to cover. Likewise for the column, if suppose any column is failing, suppose this particular column is going to fail, so I need to know what is the reason of failure of this particular column. Whether this column is short column, whether column is long column, whether this column is cylinder column, whether what is the effective length factor was calculated by the software, what does mean by this effective length factor, how this effective length factor is going to influence, what does mean by the interaction diagram, how to understand this interaction diagram, how to read these detailed results of the detailed calculation of the ETABS software. If suppose the column is going to become long column, how much the additional movement will be there. Okay, suppose the software is what designing and it is asking that 1.7% of reinforcement we have to provide in this column. So suppose my intention is that this percentage should be only 1%. So I will cross check the result of this ETABS software with my advanced Excel sheet, which is having to design for the biaxially loaded long column, cylinder column. So by using this spreadsheet you can design. You just only have to put analysis results of the ETABS software in this Excel sheet. This will give you the design result, and then only you can decide that whether the software has done the things right or wrong. Okay, so for the column, after the column, then we will look at the slab design. For the slab design we are using the advanced Excel sheet for the one-way slab, two-way slab. Okay, these are one-way slab design, two-way slab design, continuous slab design, staircase design, everything we are going to cover, because you all know slab we are not designing by the ETABS software, staircase slab we are not designing this ETABS software, foundation we are not designing. So for that we are going to take the help of our advanced Excel sheets, and this is not the practice we are going to done only, it is the practice we are done by most of the consultancies, most of the independent consultants, right? So like once you complete this, then the next step is going to start about the scheduling and detailing. Okay, so like we have to prepare the schedule of the beams. Okay, so what does mean by the schedule of the beams? Okay, so we, in respect of your ETABS result, we have to prepare the schedule, how much the reinforcement required for a particular beam, at its top, at its bottom, at its left, at its right, what does mean by the curtailment, how much the length of the hooks, okay, how much should be the development length, everything we should try to understand. If suppose you are going to detail the cantilever beam, how much the projection back side of the cantilever, okay, how much the shear reinforcement, what should be the spacing of the shear reinforcement, okay, from where you have to position your first stirrups. So everything comes under the scheduling and detailing, especially we can call it as detailing. Okay, so how, which code you have to refer for the detailing is your SP34. So we are going to look at in deep all the clauses of SP34. That SP34 will tell you how to detail, how to schedule your structure, design structure. Okay, so with all that studies and practices, we are going to prepare the schedule of your column, schedule of your beam, schedule of your slabs, okay, and then schedule of your foundations. Every element we are trying to cover. So from architectural plan to final design sheet, everything we are trying to cover for all the elements. Thereafter we will talk about the design of overhead water tank, underground water tank by using our advanced Excel sheet. Here it is what ready now. Overhead water tank, how to design that overhead water tank, underground water tank, how much the vertical reinforcement you have to provide, how much the horizontal reinforcement you have to provide. Okay, so lot of things are there. How to do the calculation for the water load over your structure, how to calculate the consumption of the water, how much the water required for a particular structure for a particular number of persons. Okay, so that all things we will do in detail. With that we will complete the design of the overhead underground water tank, and then we will prepare the details. Okay, and you all know at different stages we are going to use the advanced Excel sheets, and there are not only one and two, there are many spreadsheets we are going to use to complete the projects. Okay, so that all you will get, or whatever the Excel sheets we are going to use for the completion of the project, that you will get in the cost of the training only. There will be no extra cost for these spreadsheets, for this advanced Excel sheet. Okay, so with all of this, after the completion of the project, now if suppose you are going to complete scheduling and detailing for any project, like suppose G+5, 6, 7 floor, so it takes hell lot of time. It takes about 4 to 5 hours if you are going to do the things manually. Then the need of these RCDC software will come into the picture, that this RCDC software will help you to complete your work within a short period of time. So the time required for any project, for any structure, for its scheduling and detailing, suppose it is 4 hours. So that work with the help of STAT RCDC software you can complete within a 30 minutes. In a just a single click, it will give you all layouts, it will give you all design result, it will give you schedules, it will give you complete details. So like you have how to export the results, how to export the results of the ETABS software, then how to import that results in your STAT RCDC software, what problems you may need to face, and if suppose any kind of problem you are facing, how to tackle that problem while exporting, while importing that all results. And then you have to prepare the schedule of the beam, and then you have to prepare the details of the beam. See, in just of single click, this kind of complicated drawing sheets you are getting, drawing reports you are getting. Try to understand. Just think about if you are using the CAD, if you are going to do manually all this detailing, so how much time will you need to have for its completion. So it takes hell lot of time. That's why what we are going to study about this STAT RCDC software. Okay, then how to design the column, how to detail this column, how to draw the sectional details by using Excel sheet. In just a single click, all this thing has been done. Okay, I have not done anything. Software has done everything. It will give the sectional detail, the slab design results, everything will be there. This is a layout of the reinforcement. Okay, so this is what, in this way we are going to complete the design for all the elements. We will talk about the column, we will talk about the slab, we will talk about the foundation, we will talk about the beams. Okay, so all the elements we are trying to cover in STAAD RCDC software also. So first we will do manually, and thereafter we will look at the software. So knowing of the software is not only the solution. I am going to cover first manually. I will let you know all those things, then I will take you all on this software. So you will have the knowledge about the from basic to software, everything you are getting. Okay, thereafter in this way we are going to complete this intermediate level. So you can understand with all that study whether you will be confident or not to deal any project. Okay, so we are giving the experience of real practice. That is what the objective of this intermediate level. Okay, so in the beginner level we are making you confident with the software. In intermediate level we are giving the real experience for dealing the real example project, and now the third level we are going to start, that is what? Advanced level. Okay, in this advanced level we are going to take advanced high-rise structure. Okay, in that high-rise structure lot of things we are going to we are trying to cover that is not covered in your medium rise structure or in intermediate level. Okay, so lot of things, what are those? Try to understand, like what is the concept of stiffness, ductility and strength, what is the role of these different parameters, what will happen if your structure is having the less stiffness, less ductility, less strength, and if it is having very high stiffness, very high ductility, very high strength. What does it mean by the earthquake loading? What does it mean by base shear? What does it mean by the lateral forces at different floors? How it is coming? What is the manual approach for doing the calculation of the earthquake loading? Okay, manual calculation for the earthquake loading. What does it mean by the lumped masses? Okay, what does it mean by the base shear? What does it mean by the zone factor? What does it mean by the response reduction factor? These all values you have to put in ETABS software. So for whatever the values you are going to put in ETABS software while the assigning of the different loads like earthquake load and wind load, if you are not having the basic knowledge about that term, like suppose response reduction factor R value, many of you are knowing as what? For the R you have to put if you are going to do the ductile detailing you have to put it as 5, and if you are going to do ordinary detailing you have to put it as 3. But many times when I'm asking to students or participants why you are going to put as 5, why you are going to put as 3, so they are like not in the state to answer this question. Okay, so regional study we are going to cover here, like how much the base shear is there, what is the zone factor, what is I say by G value, what is the seismic weight, what is the general weight. Okay, so these all things we will cover with a manual approach. Okay, thereafter is what? Earthquake wind load calculation. What are the different methods for the static method of analysis, for the dynamic methods of analysis, when to perform static analysis, when to perform the dynamic analysis, what is included in static method, what is included in dynamic method in respect of earthquake loading, in respect of wind loading, what does mean the modal analysis, what is the concept of meshing, what will happen if you are not going to assign the meshing, when to perform the P delta analysis, which code it is asking to perform the P delta analysis, what is the property modifier, stiffness modifier, strength modifier, what is the role of that property or stiffness modifier, what is the load combination for the high rise structure. Okay, if suppose you are going to deal this medium rise structure G plus 4, 5, 6, 7, 8, 9, 10 number of floors, so and if it is the orthogonal building, so load combination will be different. But if you are going to deal high rise structure which is non-orthogonal, what does it mean by the orthogonal building, what does it mean by the non-orthogonal building? So for the case of non-orthogonal building, what load combination will be there? When to consider the earthquake effect in Z direction, everything we are trying to cover. Okay, then what does it mean by the modal analysis, what is the stability checks, whether torsional irregularity in the structure, everything we are trying to cover in detail for this high rise structure. Okay, how to assign the wind load over your structure at different floor. If suppose structure is 20 floor, 30 floor, 50 floor, so over the height of a structure, how to calculate the wind load, that we will see in detail. Okay, and what is the modal analysis, what is the modal response? So IS code has suggested that we have to perform the modal analysis, and in that modal analysis we have to check is there any torsion in your building or not. If your structure is subjected to any torsion, you have to remove that torsion. So here this is the modal analysis result. So in the first mode, as you can see, it is what, free from torsion. In the second mode, it is having the torsion. In the third mode, there is also presence of torsion. So you have to remove the torsion from the structure from the first mode and second mode. So what actions you have to take to avoid the torsion from the first mode and second mode? And in the third mode, if the torsion is present, that is what, acceptable. So like what is the modal mass participation, what is the base shear, what is the I can say scaling of the base shear, how to do the scaling of the base shear. Okay, what is the maximum lateral deformation limit, maximum displacement limit. If your structure exceeding the maximum deflection limit, what to do with that. Okay, what is the base shear, how to scale the base shear. So these all things we are going to cover in this high-rise structure, so that after the completion of this third level high-rise structure or advanced level advanced level, you will be able to deal any kind of high-rise structure, and you will be able to do the stability analysis, stability checks for that particular structure. So in this way we are going to cover this advanced level. Okay, so these all are the content of this complete training program. Here daily live classes will be there in evening from 7:30 to 9, and that live classes you will get as a recording in just of 2 hours. Like suppose we are going to start the session at 7:30 and it is going to complete it at 9 o'clock. So in between 11 or 12 o'clock in evening, you will get the recording of that particular session. Live interaction will be there. You can ask your doubts and question anytime with expert. We are giving the real experience. You will get the certification. Okay, so after the completion of training program, you will get the certification also. So you are getting the experience as well as certification.